Hello viewers, in today's class we are going to discuss one very important and conceptual problem from limits, right? Involving the signum function and greatest integer function, right? So here we have to find out the value of this limit where we have limit x tends to pi plus. It means we have to find out the right hand limit of this function when x approaches to pi from the right of x is equal to pi, right? And the function is signum of e minus e raised to greatest integer of sine x plus greatest integer of cos x divided by the square of greatest integer of x minus pi, right? So here we see that there are two important functions involved in this limit, that is the signum function and the greatest integer function, right? So let us start. So now here we have to evaluate the right hand limit of this function when x approaches to pi, right? So here we have say x is equal to pi, right? And we are approaching towards x is equal to pi from the right of x is equal to pi, right? So we'll take a point in the neighborhood of x is equal to pi, say pi plus h, right? Where h is a positive quantity, right? So we'll take x is equal to pi plus h, where h is a positive quantity, and when x tends to pi, then h tends to 0, right? So now in the next step, what we will do, we'll replace x by pi plus h, right? So let us call this limit as L. So now we can write L as limit h tends to 0, right? So for x tends to pi plus, we can now write h tends to 0, and we have signum of e minus e raised to greatest integer of sine x. So now we can write greatest integer of sine pi plus h, and then we have greatest integer of cosine function, so we can write cos of pi plus h, right? And now in the denominator we have greatest integer of x squared, right? So here we can now write for x we can write pi plus h, and here we have the square and minus pi, right? Now see, here we have three terms. The first one is greatest integer of sine pi plus h. The second one is greatest integer of cos pi plus h. And the third term is greatest integer of pi plus h squared, right? So here we cannot directly substitute h is equal to 0 in these three terms, right? So what we will do, here we'll take help of some trigonometry, right? So what we will do, we'll assign the values to this term, that is the limit h tends to 0 of greatest integer of sine pi plus h, and the limit h tends to 0 greatest integer of cosine pi plus h, and limit h tends to 0, and here we have greatest integer of pi plus h, right? So this problem is a very important problem, and this step is going to be very important, right? So here when we find out the limit h tends to 0, we cannot directly substitute h is equal to 0, right? So rather what we will do, we'll separately calculate these three limits, right? So the first one is limit h tends to 0 greatest integer of sine pi plus h, limit h tends to 0 greatest integer of cos pi plus h, and limit h tends to 0 greatest integer of pi plus h. So now let us quickly see the graphs of sin x and cosine x, right? So here we have the graph of sin x, here we have the graph of cos x, right? Now see, here we have sin pi plus h, right? So here we have this point as pi plus h, right? So when we calculate the value of sine pi plus h, right? So this is a very important step. So when we calculate the value of sine pi plus h, because this angle pi plus h is greater than pi, right? So we see that the value of sine pi plus h is greater than minus 1, but it is less than 0, right? Because this is the value of sine pi plus h. Similarly, if we take the graph of cosine function, then here we have the point pi plus h, right? And now if we drop a line here, then we see that this value is the value of cosine pi plus h, right? So cosine pi plus h, it also lies between minus 1 and 0. So this is a very, very important step, right? And moreover, here we have greatest integer of pi plus h, right? So we know that the approximate value of pi is 3.14, right? So pi plus h, it means pi plus h is slightly greater than uh, that is pi, or we can here write 3, because pi plus h is 3.14 something, because when we add h to pi, then pi plus h is greater than 3.14, right? So pi plus h is greater than 3, but it is less than 4. So this is also a very important point here, right? So now see, sine pi plus h lies between minus 1 and 0, right? So the greatest integer of sine pi plus h must be equal to minus 1. So here we have minus 1. So this limit, that is limit h tends to 0, greatest integer of sine pi plus h must be equal to minus 1. And similarly, the greatest integer of cosine pi plus h is the minus 1, because cos pi plus h lies between minus 1 and 0, right? So here we have limit h tends to 0, greatest integer of pi plus h. So pi plus h, it lies between 3 and 4. So the greatest integer of pi plus h is equal to 3, right? So we have now assigned values to these three limits, right? So now let us come to our limit L, right? So now we have limit h tends to 0. We have signum of e. E is the exponential number, and minus e raised to, here greatest integer of sine pi plus h. So that is equal to minus 1, and here also we have minus 1, right? And in the denominator, we have greatest integer of pi plus h is 3, right? So here we have 3 square minus pi, right? So now let us simplify this expression. And before simplifying it, we see that this expression is now independent of h, right? So we can now remove this notation of limit. So we have a signum of e minus e raised to minus 2. And here in the denominator, we have 9 minus pi, right? And see, e minus e raised to minus 2 is, it can be written as like this, that is e minus e raised to minus 2, e minus 1 over e square. So this is e cube minus 1 over e square, right? And now we know that the approximate value of e is 2.71, right? And e cube is obviously greater than 0, right? So e cube minus 1 is greater than 0, and e cube minus 1 over e square is also greater than 0, right? So this quantity, that is e minus e raised to minus 2, which is equal to e cube minus 1 over e square, this is greater than 0. So greater than 0 implies that e cube minus 1 over e square is a positive quantity, right? So inside this signum function, we have a positive quantity, right? So now here we have this limit L, and e cube minus 1 over e square is positive, right? So we have limit L is equal to signum of some positive quantity, right? And in the denominator, we have 9 minus pi, right? Now let us quickly see the definition of signum function, right? Now see, signum of, say, y is defined like this, that is, signum of y takes the value plus 1 whenever y is greater than 0, and signum of y is 0 when y is equal to 0, and signum of y is negative 1 when y is less than 0, right? So when y is greater than 0, it means when y is positive, right? Then signum of y takes the value plus 1. So here we have signum of some positive quantity, right? So L is plus 1 because signum of positive quantity is equal to 1, because this quantity, that is e minus e raised to minus 2, is greater than 0, right? So we have plus 1 over 9 minus pi, right? So the value of this limit is equal to 1 over 9 minus pi, right? So viewers, this is how we can solve this limit.